Hi. When we come back from Easter, we're going to continue our work starting off with these things called upper bounds. So I thought I'd just do a video that talked about a set that you know, or some sets that you know, and we'll put them on firm footing and think about upper bounds in the context of these sets just to get you thinking about it again. So if you look at definition 3.14, if we have two real numbers a and b and a is less than b, then the subset that we denote like this, ab with square brackets at each end, is an interval that you know well. It's called a closed interval, and it's defined to be all the real numbers between a and b, including a and including b. So if you think about this on a number line, and here's a and here's b, then we include a, we include b, and we include every real number in between them. So you'll be thinking, or you'll probably have seen that at school, and you might have even drawn a picture like that. In the same setup, we have something called an open interval. The difference here is, though, that we've got our point A and we've got our point B. We denote the open interval using round brackets, and it's defined to be all the numbers between A and B, but it doesn't include A and it doesn't include B. So we tend to denote those with open circles on A and B to denote that the points A and B actually aren't there. So I'm sure you're familiar with those two ideas. The other things that we can have variations on this are intervals that have one square bracket and one round bracket. So that just is read to mean if it's got a square bracket, that number's included. So here the A is included, but the open bracket means that B isn't. So this is A less than or equal to X less than B, or symmetrically A is less than X less than or equal to B. So this one on a number line looks like it includes A and it doesn't include B, but includes everything else in between. And this one is includes doesn't include A, does include B, and includes everything else in between. So it's just got a filled in dot and an open dot. The other things that we can think about, how about this one? What if we've got the set of x's in R such that A is less than or equal to X is less than or equal to A? What does that mean? Well, we call this a singleton set. And that's just equal to the set that contains only A. So that's just a one element set. So why am I telling you about these two intervals? First reason, of course, is just so we know what the definition of the two intervals is. But they're an example of something that we're going to talk about a little bit as we go through this section on bounds. Both of these two intervals have the property that they're bounded above. But they're bounded above in a different way, and it's a fundamentally different way. Okay, so let's think about this for a minute. So I'm going to start off with the closed interval AB, and you'll note that, thinking about the definition of what it means to be an upper bound, that B is an upper bound of the closed interval AB. Well, why is that true? Well, for all x in the closed interval AB, x is less than or equal to b because the closed interval AB we just defined to be the set of x's in R such that A is less than or equal to x is less than or equal to b. So it's absolutely clear from the definition of the closed interval AB and from the definition of what it means to be an upper bound that B is an upper bound of AB. All right, well, let's think about the open interval AB. I claim that B is an upper bound of the open interval AB as well. Why is that true? Well, for all x in the open interval AB, x is, well, it's actually strictly less than, but we can say it's less than or equal to b because a, b equals, by definition of the open interval, the set of x's in R such that a is less than x is less than b. So it's certainly true that all elements in the open interval AB are less than or equal to b, and that's exactly the definition of what it means to be an upper bound. So whether or not I've got a closed interval or an open interval, b is an upper bound of each of them. Okay, so I've told you how those things are the same, but I said there's a fundamental difference in those two situations, and on Tuesday, when we come back into the lectures, we'll talk about what that fundamental difference is. So I hope you can think about this. Maybe you'll figure it out by the time we get into class on Tuesday. Have a good weekend.